Now, good morning, students. Let us see now what do you mean by the mixtures. Now, many kind of matter found in nature are in pure form. That is, they contain only one constituent. In scientific language, matter made of only one constituent is called as the substance. For example, gold, diamond, water, chalk. Now, other kinds of substances which are made of more or two substances, they are called as the mixtures. Now, using this definition, let us see which of the following are mixtures. Now, water is made up of only one kind of substance, so it is not a mixture. Sharbat is a mixture because it is made up of water, lemon juice, sugar, and salt. Then iron is a substance. Steel is a mixture because it is made up of more than one metal, iron, cobalt, and so on. Then coal is a substance. Then air, it is made up of different gases, so it is a mixture. Copper is not a mixture. Then brass, it is an alloy, it is made up of more than two or more than two metals, so it is also a mixture. And soil is also a mixture. So now next we will see what do you mean by the elements. Now take a water in a teapot and cover it. Heat the water to boil. What do you see on the inside of the lid? Now when the teapot is heated, water in a teapot, it boils and changes into gaseous state. So we find vapors, that is steam, when we cover it with a lid. The water vapor cools down and condenses into the liquid. So we find water droplets on the inside of the lid. Now fill a water in a spray pump, spray the water and observe the spray. Now when the water is filled in a spray pump and we spray, then we see that the spray is composed of small particles of water and they are very tiny and we cannot see them individually. Now the water drop, so in the water droplets collected on the inside of the lid of the teapot are formed by the condensation of the vapor from the boiling water. Water in the form of vapor is composed of extremely tiny particles and therefore we cannot even see them. You will see that the spray is also composed of small particles of water. Similarly, all substances are made up of extremely tiny particles. So this smallest particle of the substance are called as molecules. The substance whose molecules are made up of one or more atoms which are exactly alike is called an element. Now we do not get different substances by the decomposition of an element. The smallest particle of the element are made up of only one type of atom. We cannot see atoms with the naked eye, but when crores of atoms come together, the total volume is large enough to be visible to our eyes. Now the mass and volume of atoms of different elements are different. Now to date, scientists have discovered 118 elements. Of these, 92 elements are found in nature, while the remaining one are man-made. Hydrogen, oxygen, nitrogen, carbon, iron, mercury, copper are few of the important natural elements. Now more new elements are being discovered through research work. Now, the great scientist Democritus named the small particles of elements atom because in the Greek language, atomos means indivisible. In 1803, John Dalton proposed his theory stating that atoms cannot be created or divided into small particles or destroyed. He used certain symbols to represent the element. So here you can see copper, that the circle was drawn and inside it the C was written. For sulfur, the cross inside the circle. and hydrogen for the dot for the hydrogen. Now, oxygen occurs in nature in the gaseous state. Two atoms of oxygen are joined to form a molecule of oxygen, which has an independent existence. Oxygen in air is always in the molecular state. Just like atoms, molecules also cannot be seen with the naked eye. Now, the next question is, which elements are found in air? Now we know that the elements which are found in air are nitrogen, oxygen, argon, neon, helium, and krypton. Now, is carbon dioxide an element? No, the carbon dioxide is a compound. The compound which is made up of two elements, carbon and oxygen. Are the atoms of different elements similar or dissimilar? Now, this is a common sense. All the elements are different, so naturally the atoms of the different elements will also be different. Now, what are the short forms of Dr, HM, AC? Dr stands for doctor, HM for headmaster, then AC, ADV for advocate, AC for air conditioner or alternating current, CM for chief minister, DC for direct current, like this. So we use the symbols for representing certain words. So in day-to-day life also, we use short forms in many places. A similar method is used to indicate elements. The scientist Berzelius was the first to use the present method of using symbols for the elements. Now, symbol of an element is written in the English script and is the short form of its name. Some elements and their symbols are listed in the table alongside. When the initial letter in the names of two or more elements is the same, the pair of letters is used to write the symbol. For example, we write C for carbon and Cl for chlorine. Now, here you see in the table. Now, this table is very important and you have to learn by heart the symbols of the element. Now, for example, here first one, hydrogen. Hydrogen begins with the letter H. So, the symbol of hydrogen is H. Now, helium also begins with H. So, in that case, what we do, the first letter H of helium we take and the second letter E of the spelling helium we take. So, H is the symbol for helium. Then lithium, Li, beryllium, Be. Why? Because boron, the symbol is B. So for beryllium, the second letter we take Be. Carbon, C. Nitrogen, N. Oxygen, O. Fluorine, F. Now for nitrogen, the symbol is already N. So for neon, then the second letter is taken, Ne. Sodium, the Latin name of sodium is natrium, Natrium. So that symbol of the natrium is written Na, because for nitrogen the symbol is already N. So we take the second letter of the spelling natrium. Magnesium, Mg. Aluminium, Al. Silicon, Si. Phosphorus, P. Sulfur, S. Chlorine, Cl. Argon, Ar. Potassium, K. Calcium, Ca. Carbon, the symbol is C. So for calcium it is Ca. Now for chlorine, the second letter CH must be symbol of other element. So the third letter Cl is taken. Now from the internet or reference books, obtain the information about the elements and prepare a table according to the format given below. Now in standard 10th, you will have the entire periodic table. That time all the elements and their symbols you can learn. Now, which elements do we use in day-to-day life? Are the metals elements? Now, elements are generally classified into two groups, metals and non-metals. We have studied the properties of metals such as malleability, ductility, conductivity of heat and electricity, density, luster, and sonority. Now ductility means malleability means what? The metals can be drawn into sheets. Ductility means the metals can be drawn into wire. Conductivity of heat and electricity means they can conduct heat and electricity. Density, luster means the shining, and sonority, it produces sound. The elements that do not show these properties are called non-metals. For example, phosphorus, sulfur, chlorine. The elements that show some properties of metals and some properties of non-metals, they are called as metalloids. Now this is the third group of elements. So arsenic, silicon, selenium, these are the examples of metalloids. Now we know that the wire that we see in the electric bulb in our house is made up of element tungsten. Its symbol W is derived from its German name Wolfram. Similarly, the symbol of silver Ag and gold Au are derived from their Latin names argentum and aurum respectively. Elements occur in the solid, liquid or gaseous state. Now some metals are difficult to use in pure form. For example, pure iron rust in air. Pure gold is very soft and bends easily. The properties of the original metal can be modified by mixing one or more metals in it. Such a mixture of metals is called an alloy. So brass, steel, 22 karat gold are the few examples of alloy. Now the question is here, which of the elements are metals and which are non-metals and which are metalloids? So now the examples of metals, non-metals and the metalloids we have already seen.